Welcome class, this is Professor Weathersby. In this video, we will use a router to configure a basic network. Let's begin. You'll need to have Packet Tracer open. With Packet Tracer open, on the bottom left-hand corner, select the router icon. This will present several routers that you can choose from. Let's choose the 1841, which is a relatively modern and basic router. Highlight and drag that icon for the 1841 router onto the screen. This will give you a single router named Router 0. Proceed to click on the End Devices icon, specifically the one for systems, computer systems. Go ahead and select the PC system, which should be the first icon once you've selected End Devices. Go ahead and drag that icon onto the screen, which should give you PC 0. Do it a second time, which will give you PC 1. On your screen should be a single router, Router 0, PC 0, PC 1. All three devices are currently on an on state, yet unconfigured. Let's go ahead and add a note. That way we know what our objective will be. Let's configure the IP address for PC 0 to be 192.168.1.2/24 mask. Let's go ahead and do the same thing for PC 1, but make sure we put it onto a separate subnet. In this case, let's use 172.28.1.2/24. The label or note has nothing to do with the configuration and is simply a way for the person operating Packet Tracer to see what the objective should be. Let's go ahead and also define what the router interfaces will be. Router 0's interface, one of its interfaces, will be 192.168.1.1. Note in this case, we're keeping it on the same subnet as that of the PC. Let's actually go ahead and label this as well. Let's actually assign Fast Ethernet 00 to this interface. And let's do the same thing for Fast Ethernet 01. And in this case, give it an IP address on PC1's interface, 1.1/24. With the labeling complete, we're now in a position to begin actually configuring the device. Let's start with the router. Single click on the router, which should bring up the following physical device view screen. Select the tab that says CLI. That will open up the iOS command line interface and look exactly as it would if this router were real. Type in No or N to bypass the initial configuration screen. Select Enter and you should be at the initial prompt for the router. To begin, type in Enable and hit Enter. This will take you to the Privilege Exec screen. From here, you'll need to enter the configuration mode to assign the basic configuration of a router. You can enter the configuration mode by typing in config space T and hitting Enter. This will take you into the configuration terminal mode. From here, let's go ahead and set a host name as the very first thing we're going to do. Type in the word host name space the name of the host you want to give it. In this case, let's give it something simple like R1 and hit Enter. You will notice that the prompt has actually changed to reflect the updated host name. Let's go ahead and set the basic passwords that we've seen in class. So that would begin with setting the enable password to class, enable secret class, and then hit Enter. Looks like I have a typo. This is a good example of don't freak out if you do get a typo. If it says invalid input, take a look where you see the little caret and think about what you typed in. In this case, I had a typo. I'm going to go ahead and type it back again with secret spelled correctly and hit Enter. My enable password has now been set. Let's go ahead and set the line console password and the line VTI passwords as well. Line con 0, Enter, password, in this case Cisco, Enter, and then the word login. Then go ahead and type exit, and we're going to do the same thing for the line VTY through 0 through 4. We're going to type in the word password, and then the word Cisco again, This will set the password for all VTY interfaces to Cisco. We're going to type in the word login and type exit. We've now configured the router with a host name, an enable password, a line console password, and line VTY passwords for interfaces 0 through 4. Next, what you should do, and it's probably a good idea to get in the habit of doing this when you're configuring most Cisco devices, it's type in no IP domain -lookup and hit enter. This will prevent your router or switch from attempting to do a DNS lookup if you miskey something in. From here, let's also go ahead and give it a banner. As you learned in class, typing in the word banner will present several options. To see those options, do a question mark after banner. You'll see that you have the option of setting a message of the day banner or a login banner. In this case, we're going to do a login banner. We're going to hit question mark again, which will show us some additional options. You can see that the eliminating character in this case is C. So to type in the banner message in its entirety and have it work, we're going to type in banner, login, lowercase c, our message, and in this case we're going to do a basic no unauthorized access allowed, misspells authorized. And then we're going to finish it with another lowercase c. We've now done the very basic configuration of our router. Let's define the interfaces that we noted on our document. First, we have to enter the interface. Let's first do FA00. Give it an IP address exactly as we specified. .192.168.1.1, and then a subnet mask that matches a 24-bit CIDR, in this case 255.255.255.0. We're going to give it a description by typing in the word description, and in this case let's just say link to PC0. That way we know what this particular interface will be doing. Now, before we leave this interface, it's very important that you type in the no shutdown command. The no shutdown command will activate the interface. Router interfaces are generally in a shutdown mode. Using the no shutdown command will bring them live, and it's necessary for everything to work. With interface FA00 configured, let's go ahead and set FA01 similarly. First, again, we have to go into that interface by typing in int FA0-1, hitting enter. We're going to set an IP address. And we're going to give it a subnet mask. Again, a 24-bit subnet mask. We're going to give it a description, link to PC1, and we're going to do the no shutdown command. The router is effectively completed. Before we exit the router, we're going to need to save it. But before we save it, let's take a look at what we just did and make sure everything is to our specification. If you type in N, that'll take you back to the enabled prompt, to the privileged exec prompt. And if you type in show run and enter, you'll actually see your running config. So if we scroll down, what we'll see here is fast Ethernet 00, a description of link to PC0, the IP address that we specified, and you do not see the word shutdown. The lack of the word shutdown means that the interface is active. Below that, we see FA01 similarly configured. Hitting spacebar takes you through the rest of the configuration file. We see our line password, we see our VTY password, we see our banner. Now, what I actually forgot to do is actually enable encryption of the password. It's evident by doing the show run command that these passwords are in plain text, not a very secure state. So before we actually save our configuration, we're going to go back into configuration mode, and we're going to type in service password -encryption and hit enter. That will, and we'll demonstrate by going back to the show run command, encrypt all passwords that are in the login file. This is in the startup file. This is a better practice for managing a router to avoid somebody who may be a junior administrator from seeing a password they really shouldn't. Now, with the password configured, let's go ahead and copy the configuration. Notice what I did here was use the abbreviation for copy space run config, run-config space start. I abbreviated by just typing in copy space run space start. It's going to confirm, which I can do by hitting enter, and my configuration is now saved. So that way if the router loses power, the configuration, the latest configuration that I just entered, will be present. Let's go ahead and close this router. Single click on PC0, click onto desktop, click onto IP configuration, and let's go ahead and configure it based on what we know, which is we're going to want the IP address, the IPV4 address set to 192.168.1.2 with a 24-bit subnet mask. It's already populated. The gateway, very important. We're going to configure it to the fast Ethernet 00 interface of the router. In this case, 192.168.1.1. We're going to go ahead and close this and close PC0 for now. Next, we're going to go ahead and click on PC1 and do the same thing. In this case, we're going to configure it based on the interface for FA01, which if we remember, I know this is blocking the screen. The IP address is 1.2. It's had a 24-bit mask. Notice it populated incorrectly, so we're going to have to go ahead and key this in. And we're going to have to give it the gateway, which is 172.28.1.1. We're going to go ahead and close this. Now, we've basically configured our network, but there's one important step that's missing. We're going to have to cable these devices to each other. Now, cabling is quite simple. Cabling, as I said, is quite simple. If you go ahead and click on to the lightning bolt icon, it'll give you several cabling options. Now, as you're just starting off, what I would suggest is make sure you individually select each cable type that you need based on need. If you highlight over the cable types, you'll notice below it's actually giving you the type of cable that you're going to use. For a PC connecting to a router, remember from your previous class, Cisco 1, that you're going to need a crossover cable. Go ahead and select the crossover cable. Now, if you left click onto PC0, it will present you an option on which interface would you like to connect to this cable. We've configured Fast Ethernet 0, the network interface on PC1, so we're going to select that. Next, we're going to left click onto router 0. Now, we're presented all the interfaces that router 0 currently has. Based on our note, we know that we want to connect FA00 to PC0, so we're going to left click on FA00. Notice what happened. Because it was successfully configured, both ends of the interfaces are showing green. Green is representative of a successful link. We're going to do the same thing for the other side of the interface. This time, let's click on router 0 first. Notice that FA00 is no longer present, only 01, and 01 is the interface that we want, so left click on that. Click on the PC1. You're going to be presented options again. FA0 is the only Ethernet interface present, so we're going to left click on that. And now we have a successfully functioning network. But before we close out, let's confirm. Let's confirm we have the connectivity we believe. We're going to first do that by clicking on PC0. It should bring us back to the desktop tab if it doesn't click on it. Open the command prompt, and let's go ahead and confirm. Confirmation is best done using the ping command, and we're going to try to ping its gateway. Notice the reply backs. The gateway successfully found. Now, that is only telling us that the link between PC0 and router 0 are functional. It's not telling us that it has a pathway to PC1. Let's go ahead and test. Because this is a simple lab, we can actually just, by visual inspection, see that everything's working. We're going to just confirm that with a ping. So we're going to ping. Let's first start off by pinging router 0's F01 interface and see if it's available. 172, so type in ping space 172.28.1.1 and hit enter. Notice we're getting reply backs. also means it's successful. Now, let's confirm that PC1 is also visible from PC0. Go ahead and type in ping space 172.28.1.2 and hit enter. Uh-oh, what's going on? We lost one packet, but the remaining packets are successful. This is a quirk within the packet tracer application. You may occasionally notice that the first ping is lost between interfaces. And let me more accurately say, it's not a quirk of packet tracer as much as replication of reality, where the routers and switches may take a packet or two to actually show that it's successfully transmitting. Be patient. You can see that while the first packet was lost, the subsequent 3 packets were successful. If you're concerned, hit the up key, ping it again. What you should notice that all 4 packets are successful. So that concludes this basic introduction of packet tracer. We were successfully able to set up a basic network and ping from PC0 on one interface to PC1 connected to another interface. Look for additional videos on how to use packet tracer as well as how to set up more advanced networks. Thank you and have a good day.